Okay class, now we're going to see another example of undetermined coefficient methods to solve the non-homogeneous equation. So in this example, you are given the differential equation of this particular expression, and you are given the initial value of x at t equivalent to 0 is equal to 7, and the differentiation of dx with respect to t at t equals to 0 is equivalent to 2. So you need to find the solution to this problem. So the first step is we need to find the complementary function. The complementary function is corresponds to the associated homogeneous equation of this non-homogeneous equation. So in this case, we have 3 x double prime minus 2 x prime minus x is equivalent to 0. So we're going to replace the x double prime with m squared and x prime with m. So in this case, we need to find the roots of the homogeneous equation of 3m squared minus 2m minus 1 is equivalent to 0. Okay, when we factorize this expression, so we're going to get a factor of 3m plus 1 and m minus 1 is equivalent to 0. So this will give us a root of 1 over 3 and 1. So solving for this homogeneous equation, it will give us the complementary function of xc is equivalent to a exponent minus t over 3, which comes from the first root that we have, which is minus 1 over 3, and plus with b exponent t, which comes from our second root, which is m2 is equivalent to 1. So the next step is we need to find the particular solution. Okay, for the particular solution, we need to refer to the function of x, non-homogeneous equation. So if we look at the differential equation, in this case t, the function t is in the form of 2t minus 1, which is the polynomial form. So our particular solution also will be in the polynomial form. Therefore, the particular solution for this, it will be in the form of ct plus d. But before we verify that this is the correct assumption, we need to see the pattern of this xp, whether they are similar to the complementary function that we have obtained. If we compare the particular solution, the pattern is not similar, so therefore this is the right guess that we make. Next step is we need to find the differentiation of this particular solution. So we differentiate this with respect to t, so we get the xp prime, which will give us c. Okay, similarly we need to find the double prime of this, because our expression comprised of the second order differential of x and the first order of the differential x. And because there is no variable t in this xp prime, therefore we get the xp double prime is equivalent to 0. The next step, what we need to do is we need to substitute the expression. So if we look here, we have this 3 multiply with x double prime. So since x double prime is 0, so we have 0 for that part. Okay, so 3 times 0 minus 2, okay, times with x prime. So x prime is only c, okay, minus with x. So x is ct plus t is equivalent to 2t minus 1. Okay, so we have minus 2c minus t minus ct is equivalent to 2t minus 1. Then we will compare the coefficient. First we compare with t. So if we have t, here we see that actually t is minus c is equivalent to 2, which gives us c equals to minus 2 for t0, or simply a constant. So we have minus 2c minus d is equivalent to minus 1. So we substitute c equals to minus 2 inside this expression. So it will give us 4 here, right? It will give here 4. Therefore, d is equivalent to 5. Having obtained this, now we can get the particular solution, whereby we substitute the value, which is equals to minus 2t plus 5. So now we can get the step 3, which is the general solution. General solution comprises of the complementary function plus with the particular solution, which is going to give us a exponent minus t over 3 plus with b exponent t minus 2t plus 5. So the black color one comes from the particular solution and the red color comes from the complementary function. We are not complete yet because we are given the initial values. X at t equals to 0 is equivalent to 7, and the differentiation of x with respect to t at t equals to 0 is equivalent to 2. So we need to make use of this initial value to obtain the constant a and constant b. For x expression at t equals to 0, so we substitute this inside the expression here. So we're going to get a times with the exponent 0, which is going to give us 1. So we have a plus b, and this part minus 2 times with 0 will give us 0. And then 5, okay, so that's why we have a plus b plus 5 is equivalent to 7. This will give us A plus B is equivalent to 2. So let's say we call this one as equation 1. For dx 0, we need to differentiate this expression first. Okay, when we differentiate x with respect to t, we're going to get minus 1 over 3 a exponent minus t over 3 plus b exponent t minus 2. When we substitute t equals to 0 into this expression, it's going to give us minus 1 over 3a plus b minus 2 and is equivalent to 2. So when you rearrange this, you're going to get b is equivalent to 4 plus 1 over 3a. So we name this as equation 2. Okay, by solving equation 1 and equation 2, we're going to get the value of a and b. So in this case, I substitute the equation 2 into equation 1. So I will have a plus 4 plus 1 over 3 a is equivalent to 2. 4 over 3 a is equivalent to, so 2 minus 4 will give me minus 2. So in that case, I will have a is equivalent to minus, so 3 over 2. Once we have obtained the value of a, then we can get the value of b. Okay, so we substitute this inside the equation 2. Okay, so you have b is equivalent to 4 plus 1 over 3 multiply with minus 3 over 2, which is going to give me, so 8 minus 1 over 2 is going to give me 7 over 2. Solution for the DE is, so we already know the value of a, so the value of a is minus 3 over 2. So we replace this with minus 3 over 2. Don't forget the minus sign. Okay, and b is 7 over 2. So this is our final solution. Okay, thank you for your attention. If you have any questions on this method, feel free to WhatsApp me. Thank you.